solving a two-port network problem using Z parameters. Here we have a two-port network consisting of resistive elements, 4 ohms, 5 ohms, and 8 ohms. We have the input port here on the left with V1, the output port here on the right with V2. All right, the current I1 is entering port 1, current I2 is entering port 2. The problem is find the current delivered to a 50 ohm load when supplied with 10 volts at the input port. So first of all, we want to find the Z parameters for the circuit and then use those parameters to solve for when we have a 10 volt supply, voltage supply, and a load of 50 ohms at the output port. All right. So here we have the equations for the Z parameters. V1 is equal to Z11 I1 plus Z12 I2, and V2 is Z21 I1 plus Z22 I2. And our first step is to find the Z parameters Z11, Z12, Z21, and Z22. So we're going to proceed by applying Kirchhoff's voltage law. We're going to apply Kirchhoff's voltage law to this network. Okay? So we're going to apply Kirchhoff's voltage law to this network. Right. So for V1 is equal to 4 I1 using Kirchhoff's voltage law in this loop. 4 I1 plus 8 I1 plus I2. So we get that V1 is equal to 4 I1 plus 8 I1 plus 8 I2. This gives us that V1 is equal to 12 I1, 12 I1 plus 8 I2. And that gives us our equation 1. All right. Now, V2 will be equal to 5 I2 plus 8 into I1 plus I2. I2 plus 8 into I1 plus I2 equal 5 I2 plus 8 I1 plus 8 I2 equal 8 I1 plus 13 I2. So that's our V2. If we now compare with the um, Z parameters equation, we can then write down the values of Z11, Z12, etc. So Z11 would be here, would be 12. So Z11 equals to 12. Z12, Z12 would equation for the voltage. Z12 will be 8. This will be ohms, of course. Z21, look into voltage V2. Z21 will be 8 ohms. And Z22 would be 13 ohms. Okay, so those are the parameters, the Z parameters for this circuit, right? Z11, 12 ohms, Z12, 8 ohms, Z21, 8 ohms, and Z22, 13 ohms, right? We will continue to solve the problem by first of all drawing the equivalent circuit and then solving for the input voltage of 10 volts with a load of 50 ohms. We'll do that in the next slide. Please note that the voltage sources inside the two-port network are dependent sources. Dependent sources are not independent, as they have sometimes erroneously termed them. So the sources within the two-port network, the voltage sources are all dependent voltage sources. After we have found the Z parameters, Z11, Z12, Z21, and Z22, the next step is to draw the equivalent circuit to represent those Z parameters. So here we have the two-port network, and we have Z11, and this is an impedance, and here we have a dependent voltage source that depends on the current in I2, the current in port 2. So you have Z12 times I2. Over here, we have an impedance, Z22, and that is in series with a voltage, a dependent voltage source, right? That depends on the current in I1 in the opposite port. Okay, so we now proceed to solve for I1, I2. Then once we find the value for I2, once we find the value, the equations for I1 and I2, we'll substitute the value for I1 as is equivalent in relation to I2 in the equation, and then we can finally solve for I2 to find the current in the load. All right, so here we have the supply that we're going to connect to. We're going to connect the supply to the input port. Okay, and we're going to connect the load to the output port. Okay, All right, so let's solve. So our first step is to find I1. Now what is I1? I1 is in this loop here. This loop has in the voltage source, but it also has the independent um, voltage source. The independent voltage source is in opposition to the supply voltage. So to find the current in this loop, we're going to take away the voltage in the dependent voltage source, take that away from the supply voltage and divide by the impedance, right? And that would give us I1, right? So we can write that I1 is equals to 10 volts minus this voltage is um 8 ohms, so that's 8 I2, right? So this voltage here is simply 8 ohms multiplied by I2, right? And all of that, to get I1, we divide by 12 ohms. So that would give us I1, right? So we get that 12 I1 multiplied is equals to 10. You're going to leave off the volts, 10 minus 8 I2. So we get that 12 I1 plus 8 I2 equals to 10. All right, so that's our equation for I1. Next, we need to find the equation for I2. Now note the polarity of the independent voltage source that's going to force current through the load. But note the current will be opposite to I2, right? The current will be delivered uh, from the potential of this voltage source is going to flow in this direction. So we have to say that the current delivered because of this source through the load would be negative I2. So what is it? It is simply this voltage here divided by the sum of this impedance and this resistance. All right, so we can say then that, let's separate this down, minus I2, negative I2 is equal to 8 by I1, this is the voltage, 8 ohms by the current, 8 I1 divided by 13 plus 50 ohms. And if you solve that, follow that all the way through, you're going to get that. All right, let's go through it then. So we get that negative 63 I2 is equal to 8 I1. So we get that I1 right? So we get that negative 63 I2 is equal to 8 I1. So we want to find out what I1 is in terms of I2. So we have that then. We have that I1 is equal to negative 63 I2 divided by 8. So we get that I1 is equals to 7.875 I2. Right? So now we can take this value, sorry, this is I1. We can substitute it into this equation here, and then we'll have I2s, and then we'll solve for I2. Remember, our aim is to find the value of I2 flowing through the load. All right? So let's do that. So we're going to say now, substituted for I1 in here, we're going to say that 12 multiplied by, oh, by the way, this should have been a negative, right? This should have been a negative, right? I1 is negative 63, I2 on 8 is I1 is negative 7.875 I2. So we have here that 12 multiplied by negative 7.875 I2 plus 8 I2 equals 10. So we get negative 94.5 I2 plus 8 I2 equals 10. So negative 86.5 I2 equals 10. So we get that 2 equals to, and it comes out to 116 milliamps. Okay, so I2 becomes 1. Okay, negative value, negative 1.116 milliamps, which says that our current is not in this direction, but our current is flowing here. So we have that the current through the load is actually, let me change color of the pen. The current through the load is in this direction, 116 milliamps. Okay, so that's the end of the demonstration of the calculation. So we first of all, we found the Z parameters for the original circuit. Then we drew the equivalent circuit. Right? Then we added on the voltage source and the load. We calculated for I1, right? Calculated for I1 using port 1. We then calculated for I2 using port 2. And then we found the value of I1 from that. So we found I2, but then we found out what I1 is in terms of I2. And then we use that value for I1 to substitute it in this equation so that we have all I2s, and then we solve for I2, and we got a value of negative 116 milliamps. All right. So thank you for watching.